So today's curve sketching problem is y equals to x times e to the negative x. So first you want to find the derivative. I mean, that's the most fun part, right? Finding the derivative. The other ones might take more effort. Okay, so finding the derivative. It's a product, so what rule do you have to use? So differentiate the first plus differentiate the second. And derivative of x is 1 plus, actually, if you differentiate this, using the rule e to the ax prime equals to a times e to the ax, there's this negative 1 in front of x, right? So for this formula, a is like negative 1. So that negative 1 comes in front, giving you that negative of x e to the negative x. Okay. Now you have two terms, and they both have e to the negative x as a common factor. And since we are trying to use this for finding extrema and all that, it's good if you can simplify as much as possible. So let's factor out the e to the negative x. Once you factor the e to the negative x, then what's left inside the parentheses is this 1 to the negative x that's left inside. Okay, so that's the first derivative. Now what about the second derivative? You have to differentiate the first derivative again to find the second derivative. So you differentiate the first, differentiate the second. That differentiates to negative 1. And then this thing again differentiates to minus e to the negative x. So this minus came from the fact that you're differentiating e to the negative x, negative comes in front. And you can simplify it again by factoring the e to the negative x out, which leaves you with negative 1 minus 1 minus x. And let's try to simplify this. Negative 1 minus 1 gives you negative 2. And negative of negative x gives you positive x. So it's x minus 2 e to the negative x. That's how you can simplify it. Okay. Now, from this, you can figure out the points where y prime is 0. When is y prime 0? When x is 1. See, can an exponential function be ever 0? No. So the only way that this could be 0 is when 1 minus x is equal to 0. That only happens when x is equal to 1. How about this one? When is this 0? 2. When x is 2. So at x equal to 1, you're going to have, x equal to 1 is a critical value, critical number. And therefore, there's a possibility that x equal to 1 could be a relative minimum or a maximum. And for this one, you can also say x equals to 2 could be an inflection point. Okay, let's try to figure out the sign of y prime and y double prime from this. So y prime. How do we determine the signs again? We first figure out the points where y prime is 0. We already agreed that it's going to be 0 at 1. We pick test points before and after. So a number before 1 that's pretty simple is 0. A number right after 1 is 2. Let's plug in 0 to this function. See, exponential function is always positive, so we don't care about the sign of this. If you plug in 0 for 1 minus x, do you get a positive or a negative?
Positive.
Positive, because 1 minus 0 is 1, that's positive. Positive times positive is positive. So at 0, you write down positive. How about plugging in 2? 1 minus 2 gives you a negative 1, so that's negative times a positive, that's a negative. So already from here, we know that y will be increasing and then decreasing, so at 1 you're going to have a relative maximum. So we're going to think about that along with the y double prime once we get it. Now let's figure out the y double prime. Y double prime is 0 when x is 2. Let's plug in 1 and 3, two numbers before and after 2, into the second derivative to figure out the signs at these intervals. Okay. So if you plug in 1, 1 minus 2 is negative, negative times positive is negative. If you plug in 3, 3 minus 2 is positive 1, 1 times positive is positive. And this says it's concave down, and this is concave up. Now, it's helpful, therefore, to find out the value of the function at 1 and also at 2. So let's identify some points. First, I guess before finding the location of the inflection point and the relative maximum, we should also find the y-intercept and x-intercept if that's given. So what's the x-intercept? To get the x-intercept, you set y equal to 0. So you can say 0 is equal to x times e to the negative x. And since this is never 0, the only way this could be 0 is when x is equal to 0. So x equal to 0 is the x-intercept. For the y-intercept, you set x as 0, so y is equal to 0 times e to the negative 0. That's again 0. So you can see that 0, 0 is the only x-intercept and also the y-intercept. So both of the calculations shows you that 0, 0 is the only point that where the graph crosses any of the axes. So other than this location, the graph is not permitted to cross the x-axis or y-axis. Okay. And then now let's figure out the relative extrema. What is y at x equal to 1? So the value of y when x is equal to 1 is 1 times e to the negative 1. So it's e to the negative 1. So, and this is something that you can just leave it like that. There's no problem. But if you don't like negative exponents, you can rewrite this as 1 over e. I kind of like this better. 1 over e seems easier for me, but it doesn't matter if you write that. Now, what about the inflection point? Since there's a change in concavity, this x equals to 2 is an inflection point, and we want to find out the y-coordinate of the inflection point. X equals to 2. That gives you 2 times e to the negative 2, because I'm plugging in 2 in here. And again, using the fact that negative exponent means 1 over the positive exponent, we can rewrite this as 2 over e squared. It also helps if you know the approximate value of e. E is 2.7 something, so you can kind of think of this as like 1 over 3, and this is something like 2 over 9, so approximately. That kind of helps you to picture what's going on. Okay? So it seems like this is smaller than this, because 1 over 9 is like 3 over 9. This is 2 over 9. So this is slightly less than this one. Now, thirdly, you have to identify any kind of asymptotes, if there is any. Now, does this have any vertical asymptotes? One way to figure out the vertical asymptote is to set the denominator equal to 0. And this does happen to be a fraction if you write it in that form. E to the negative x is e to the x in the denominator. Right? So it's x over e to the x. And So if the denominator e to the x is equal to 0, then you would have a vertical asymptote. However, e to the x is always positive. It's never 0. So there's no way that the denominator can be equal to 0. Therefore, there's no vertical asymptote. So there's no vertical asymptote. However, there is a horizontal asymptote. How would you find horizontal asymptote? Send x to what? Infinity. Okay, for this limit, x grows like it's a linear function. The graph of this thing is linear. It just grows like that. Whereas e to the x grows like what? Exponentially. Well, it's an exponential function, so it grows exponentially. So if you plug in bigger and bigger numbers for both top and bottom, they both go to infinity, but the bottom one goes to infinity much faster. So if you think about this as like 3, even for x equals to 3, you have 3 over 3 to the third power, which is like 1/9. So it's already very, very small. And you can plug in more and bigger numbers to see that this does go to 0. So the limit will be 0. However, if you take x going to negative infinity, let's think about this, x times e to the negative x. What will be the limit of this? Okay, well, negative x goes to negative infinity, so it's negative infinity times e to the negative of negative infinity. So this is e to the infinity, right? What would you get if you take e to the infinity? Take e and you multiply e 2.7 to itself many, many times. You get positive infinity, right? So what do you get? Infinity times infinity. Two very, very large numbers multiplied together produces infinity, but it has a negative sign, so it will be negative infinity. So we know that as the graph extends to the right, it will get closer and closer to the x-axis, whereas when you send x to negative to the left, it will go down to negative. So these are the information that we can get from here. Now let's try to summarize what we found out and then use that to draw the graph. Okay? So let's see. You have before x less than 1, y prime is positive. And then what about y double prime? It's negative because it's before 1, so it's somewhere here, it's negative. And between 1 to 2, y prime changes sign from positive to negative, right? Whereas because it's still before 2, y double prime is still negative. And then after 2, y prime is negative, but y double prime is positive. So these are, this table basically contains all the information that we can get from the derivative, first derivative and the second derivative. So that's one thing. Along with this, we have that graph passes which point? 0, 0, 1, 1 over e, 2, 2 over e squared. Those are the points that we figured out. So now we can erase this one. And then finally, we found out that there's a horizontal asymptote. There's no vertical asymptote, but there's a horizontal asymptote. It's the x-axis. Or in terms of the equation, you can say y is equal to 0. That's the x-axis. And the end behavior on the left side is if you send to negative infinity of this f of x, it gives you negative. So that's all we figured out about this function, and that should be enough for us to draw the graph. So now let's try to draw the graph. You have a question?
Just like the second limit x to negative infinity.
Mm-hmm.
I thought that if they don't converge, then there are two asymptotes. Would you agree?
Oh, so this one we got by finding the limit x going to the right. If this one also converges to some other value, then you might have two horizontal asymptotes. That could happen. But for us, because the left side does not converge, we only have one asymptote.
Okay.
Often for rational functions, the limit going to the right and the left are exactly the same. That's why for rational functions, a lot of times you have a single horizontal asymptote. Yeah. But this one has an asymptote that's only describing the right side behavior. Okay. So let's try this. Oh, first let's try to figure out the behavior of y. Now, y prime is positive. What does that mean? Y is increasing. Y is increasing. Now, y double prime is negative. What does that mean? It's concave down. Right? Or another way to think of it is that you're pushing this rubber bar from below, so it's going to bend, right? How is it going to bend? It's going to bend like this. Now in this case, because y prime is negative, it's going to go down. And again, you're pushing this from below so that it's going to bend like this. In this case, it's still going down, but this time you're pushing from above, so you push it from above. So, bend like that. Let's put everything on the graph now. For 0, 0 is here. And let's just say, because we have no idea what exact value of 1 over e is, let's just say this is 1 over e. And we know that 2 over e squared is just slightly less than 1 over e. Let's just say this. And then if this is like 1/3, let's just say this is 1 and that's 2. We're just sketching it, so we don't have to have exact values. So at 1, it has to pass through this point. At 2, it has to pass through this point. Now let's try to draw it. From negative infinity to 1, it has to be of this shape. So we're going to draw that shape. And this matches with this requirement that as x goes to negative infinity, as x moves to the left, it goes down to negative infinity. And then from here to there, we have to take this shape and paste it. So we're going to paste it. Remember, this point has to be relative maximum, so we can't go up, we have to go down. Like that. And concavity should be. Okay. So, just like that, and pasting it. And then, from 2 to infinity, it has to have this shape. And remember, because the x-axis is an asymptote, the graph has to get closer and closer to the x-axis. That's the graph.